Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Hello everyone. Today in this video, I will try to explain about piping network. It is the next material before we discuss in the last week about it was about branching pipes. So today we will study about piping network. If you imagine that PDAM, PDAM, Perusahaan Daerah Air Minum, using the complex network of pipes. So in this material, we only study about the simple piping network. One of the method is Hardy-Cross method. The aim is efficient flow distribution. In the Hardy-Cross method, it was using iteration method, and for sigma Qi equals 0 and sigma HF equals 0. HF is major loss, and we're using Darcy-Weisbach. So if the constant of this in a formula, we can write in K. So HF equal K times Q square. HF equal K times Q square equal Q in the bracket QO plus delta Q square. Delta Q is the error because we want to have result Q in equals Q out. So it must has the value of Q in minus Q out is 0. But if there is a number about the delta Q, so it is the error. And we can write in the mathematical operation K Q square QO square plus 2 times QO times delta Q plus delta Q square in the bracket equal K QO square plus 2K times QO times delta Q plus K times delta Q square. Because delta Q is less than 0, so that delta Q square equals 0. So we can ignore the value of delta Q square. So we can write HF equals KQ square plus 2 times K times QO times delta Q. because in the Hardy cross method, sigma HF equals 0. So we can write delta sigma HF equal sigma K times Q squared plus sigma 2K QO times delta Q equals 0. Because we want to know the value of delta Q, so delta Q equals sigma K times QO squared over sigma 2 times K times QO in absolute. Why absolute? Because if you know the error value is can be minus or positive, so it must be absolute. Sorry, it is in Indonesia, so you can see this slide. Hardy cross procedure number 1. Choose the distribution of flow rate or QO through each pipe until the continuity requirements are met. Did you know that the continuity equation, it must be Q in equals Q out. So you have to know the direction and magnitude, or you have to assume the direction and magnitude of the flow in each pipe. Number 2, the pipe network is divided into a number of networks so that each pipe is included in at least one network. Number 3, calculate the energy loss in each pipe using the formula HF equals KQ squared. So you have to calculate K times Q squared in every network, in every pipe, in every network. Number 4, calculate the total of energy loss around each network. Sigma HF. If the flow is balanced, the value is 0. So you can calculate the sigma of HF in every network is 0. Because Q in equals Q out. Number 5, calculate sigma 2 times K times Q in absolute for each net. Number 6, calculate the flow rate correction so that the energy loss is equal or balanced. Flow rate correction is delta Q. So you have to find this delta Q. And the last one, number 7, the corrected flow rate, or you can use symbol Q for the corrected flow rate. Q equals QO plus delta Q. Repeat procedure 1 until 6 until delta Q is 0 or with correction. The correction is delta Q over Q smallest times 100%. Or usually we use 5% for delta Q. This is the example exercise. A piping network as illustrated. This is the simple one. Calculate the discharge and its direction for each pipe. If M equals 2, or we can use the Darcy formula, HF equals K times Q squared. The first, we have to understand the Q in and Q out. Q in the network, the pipe in the pipe network is QR, and for the Q out is in B, D, and C. The number of Q is 20 plus 50 plus 30. So the total is 100. Q in equals Q out. And we can see that the pipe have no direction, and the magnitude, yeah. So we can assume the direction and the magnitude of the flow in this pipe, in every pipe. We can the first trial, we can assume the direction of the flow because this is Q in point A, 100. So Q out have to in 100 also. So we can assume 70 maybe and 30 in this direction. And we have to divide this network into network 1 and 2. In point B, the Q out is 20. So we have to assume the value of the discharge in direction or out direction. 70 have direction in or enter in point B and out in 35 and 15. So we can calculate that in point B have Q in 70 and Q out 20 plus 15 plus 35. Q in equals Q out. If it is okay, we can change or move to point D. In point D, Q in is 50. So we can assume that in point D, Q in is 15 and 35. So Q out is 50. Q in equals Q out. It is okay. So we move in point C. Uh, we have to uh, ensure that Q in equals Q out. Q in point C, they are 30 and 35, and Q out 35 and 30. So Q in equals Q out. It is okay for the direction and magnitude of this network. And the second one of procedure, we can calculate the HF or major loss, K times Q squared. K pipe AB, we can divide in two networks, network 1 and network 2. Pipe AB, pipe BC, and pipe AC, pipe BC, pipe CD, and pipe BD. And about K, 2 for AB, 1 for BC, for AC, and you can see in this network K115. And QO, we can write 70, 35, 30, 35, 35, 15, and we can calculate the KQ square and 2 times K times Q in absolute. And don't forget about the direction. We use two assumption about the direction. If the direction is clockwise, so you can write in positive for the value of KQ squared. But if it was opposite, you can write in negative in the value of K times Q squared. In network 1, we can see 70 has clockwise direction, and 35 has clockwise direction, and for 30 has opposite direction. So you can write in negative 3600. Okay, and delta Q is the value of the sigma KQ squared over sigma 2 times K times Q in absolute. So the value of delta Q is 13. And about in network 2, delta Q is 5 negative. Because the delta Q is positive, so for the next procedure, you have to continue the trial, because the value of delta Q should be 0. But in this trial, or the first trial, we have 13 and negative 5. So we continue the trial with this number because we have assumption about the direction in network 1. Network 1 have delta Q 13. So if it has positive value, if in the network 1 has clockwise direction, so the value in this pipe have to minus 13. But if it was opposite, it had to add 13. In network 2, we have delta Q 5, so if the direction is clockwise, you have to add 5, but if it is opposite, we have to minus 5. In the second trial, we have a clockwise direction, so we have to minus 70 minus 13, and in the opposite we have to add 30 plus 13, 43. And because pipe BC in the both of the network 1 and 2, so it have two times analysis in network 1 and network 2. Network 1 it has clockwise direction, so 35 minus 13 equals 22, and the network 2 it has opposite direction, so it have minus 22 minus 5, so it is 17 for the flow rate of PC. And the network 2, this is clockwise direction, so 15 plus 5 equals 20, 35 minus 5 equals 30. Okay, I hope you understand. I hope you understood. Sorry. And for the trial 2, you have to calculate the number of k q square and 2 times k times q in absolute. So you have delta q, -1 and 3. Negative, so if it has clockwise, you have to plus 1, add 1, but if it has opposite, you have to minus 1. And it is also in network 2 because it is positive, so if it has clockwise direction, the discharge have to minus, but if it is opposite. It has two F. Plus 1 minus 1 plus 1 plus 3 times 2 times, yeah, 2 times in network 1 and network 2 for the C pipe. And in the third trial, we can find the delta Q is 0. So uh, it is the finish to trial again. So it is the Q or flow rate in this pipe, in this network. AB has 58, AC has 42, BC has 21, DC has 33, BD has 17. That's all I think that I can explain to you. I hope you understood about the piping network. So if you have question, you can ask me in Google Classroom or in the next meeting. Okay, see you later. Goodbye. Assalamualaikum warahmatullahi wabarakatuh.